Let's talk about naming, okay? Nomenclature. How do we name compounds, molecules, chemicals in general, okay? There's several different ways of naming a compound. Yeah, I mean, there's a long list that you can go through, but I'm gonna break it down for you, okay? There's basically three types of classifications that you want to know. You have metal. Let's go there. Metal, non-metal. We have non-metal. Say this is number one. This is number two. We have non-metal, non-metal. Okay. Three would be transition metal and non-metal. All right, metal, non-metal. There's nothing really special about them, so we'll leave that blank. But non-metal, non-metal, they have prefixes, and we'll get to that. Over here, they use Roman numerals. All right. So let's do the metal, non-metal. Okay, let's do that one first. That starts off with, say, for example, we can do sodium chloride. All right, we can do NaCl. This is also sodium chloride. All right, as you notice, this first portion, the metal portion, all right, it stays consistent. I'm not changing it. I'm not modifying it. That should stay the same. What changes is the non-metal portion. The non-metal portion is what primarily changes when it goes into anionic form. Okay, chloride. Remember, chloride is -1. And the way I know that is that we can look at this periodic table I have, which will, be really awesome. Okay, so if we imagine, and we have our hydrogen up here, everything up here is +1, +2, these vary, and then we have basically +3. We're not going to do carbon because that can vary. Usually it's between -4, +4, but it can vary quite a bit. Then we have nitrogen, oxygen, and fluorine. And then we have our noble gases, which we'll just abbreviate Ng. The way this is going to go, this is -3, -2, -1. This is for everything down in this way. Okay, so when we're looking at this, we can break this up into Na plus, which obviously in this first column, and then we have Cl minus, which is going to be right underneath fluoride. Okay, so it's going to be chloride. All right. The nonmetals tend to end in "ide" because they have that negative component. So if you see "ide," that gives you an indication that it's going to be more likely anionic or some type of negative charge. All right. Let's say, for example, calcium. Calcium would be in this column. So it's going to be calcium 2 plus, and then let's say Cl minus. This would be called calcium chloride. All right. Now, one other thing that you want to note about these guys is that you're always trying to get the empirical formula for metal non-metal interactions. I repeat, you always want the empirical formula for metal non-metal interactions. Okay, don't apply this to non-metal nonmetals. You lose a lot of structure and just overall identity when you use the empirical formula for non-metal non-metal interactions. I'll give you an example. Let's say, for example, I need to reduce um, copper copper 2 sulfide, maybe. We can do that. That is Cu, and we're going to talk about how we name this. Copper 2 sulfide. So CuS is actually what it is. But this is copper 2 plus, and this is sulfide, which is 2 minus. When you look at this, this is Cu2S2, which basically breaks down into, since find a common denominator, you can do CuS. It's back to this. This is the empirical formula. As a metal-nonmetal interaction, again, we're going to learn how to name transition metals and nonmetals soon enough. But you really want to watch out for that. For nonmetal interactions, let's say, for example, we have C6H12O6. Okay, we all have seen this one before. The problem, though, if we tried to break this into empirical formula, we get CH2O, which is also known most often as formaldehyde. Okay, there we lose our functionality. Now, this is the empirical formula, right? But this is the empirical formula. What I'm saying is we don't lose what we were looking for in this versus this. We lose a lot of different things. So I repeat, do not use the empirical formula for non-metal interactions. All right. So with that being said, let's keep it going. Let's keep it moving. Let's look at some more examples as far as metal-nonmetal interactions, and specifically alkaline earth metals. So alkaline earth metals, let's say, for example, I have sodium sulfide. So sodium sulfide. All right, sodium sulfide. So we know sodium is Na. It's Na plus, and we're going to be using what we call the cross method to figure out where these charges or ions, remember ion is a charged particle, where all these ions are actually ending up. So if we look at this, and we're looking at sulfide, remember S is going to be 2 minus or minus 2. They're interchangeable most often. Depends on who you talk to and which direction that charge actually is being manipulated. But we can put them either way the same. Okay. So if we do this, we can transfer this charge over here and this here. It may be a little bit confusing, but we have Na2S. Okay, Na2S, which is the sodium sulfide that we were looking for. Remember, we can go back, Na plus, S2 minus. Okay, let's look at another example. Let's calcium sulfide. This is going to be very similar to this case. So calcium sulfide. All right, calcium is 2 plus, and that's the second column. And we have sulfide 2 minus. When we're looking at this, we can cross these charges, and we essentially get Ca2S2. Empirical formula tells us is CaS. Okay, always remember that empirical formula. Now, as we go a little bit further, we can keep testing a few other things. We're also going to be testing polyatomic anions soon enough, but I'm going to leave that for a different discussion. All right, let's try one more. Let's do barium chloride. So barium chloride. So barium chloride is going to be a 2 plus and chloride minus. Remember, we can switch these. Therefore, it's going to be BaCl2. Okay. Now let's talk about nonmetals. We're going to get to transition metals soon enough, but nonmetals don't take too long. So let's say we have N2O4. N2O4, the way we want to name it, since it deals with prefixes, is going to be dinitrogen tetroxide. Now I want to point something out. Older versions use tetraoxide. Okay, the newer ones use this one, tetroxide. Okay, we can also do CO, which you may be very familiar with this one. This is carbon monoxide. Now, carbon monoxide is very special. The mono is only used for the second atom. Do not use it for the initial atom. It should not be monocarbon monoxide. Okay, so it should just only be carbon monoxide. And you have CO2, which is going to be carbon dioxide. Okay. Remember, prefixes. We need prefixes for nonmetals. Okay. Now, if we look at transition metals, remember transition metals use Roman numerals. Okay, transition metals use Roman numerals. So if we want to name something such as FeCl3, what we want to do is, first and foremost, let's identify what the charge of that metal is going to be for chlorine. So chloride is going to be -1. So if we look at that FeCO3, this is -1. If this whole side is going to be -1, this is 3, then in order to balance this out, this has to be +3. Okay, this has to be +3. So it's going to be Fe +3 and Cl -1. Therefore, this is going to be iron 3 chloride. Okay.